In this section, we will learn about the product and the quotient rules of differentiation. So here is the definition of the product rule. Suppose the function f of x is defined as the function u of x times v of x. So you are seeing the product of two functions here, u and v, where u and v are differentiable functions. Then the derivative of f of x is the derivative of u times v. So you are replacing f by u times v. So you fix the first function u and you derive the second function v. You fix the second function v and derive the first function u. So let me name this as the first function and the second function. You fix the first, derive the second, fix the second, and then you derive the first. So the d over dx can also be written in the prime notation. So let me rewrite this definition in the form of a prime notation. So say f equal to uv, and you want to derive f, which is f prime, and you want to derive uv, which is still a prime. So fix u, derive v, which is v prime, plus fix v, derive u, which is u prime. So all you do is fix one function and derive the other. So in this first example, you have product of two functions and you're asked to differentiate the given function. So let me write the first function as u and the second function as v. So u is x squared plus square root x and v is e to the x. Now let me derive u. Derivative of u is du over dx, which is also u prime. Derivative of x squared using the power rule is 2x. Derivative of square root x using the power rule is 1 over 2 times square root x. Derivative of v with respect to x is dv over dx, which is also v prime. Derivative of exponential is the same, exponential function. I want you to make a note of deriving a square root functions, which you will see many times in differentiating. So suppose you have derivative of root x. Root x can be written as x to the 1/2. Now you want to do the power rule of differentiation. So this is 1/2 x to the 1/2 minus 1. So it's 1/2 x to the negative half. This can be written as 1/2 and then the x to the negative half can be written as in the denominator root x. So we started with deriving a root x function and all we have is 1 over 2 times the same root x function. So I want you to remember this in words so that you can avoid all these calculations whenever you see a square root function differentiation. Differentiation of any square root function, I'm going to name it as a star. This will always be equal to 1 over 2 times the same square root function star. So whatever you are deriving the square root function, answer will be 1 over 2 times the same square root function. So this lets you to skip all these power rule steps, whereas it's an inbuilt power rule and the format is 1 over 2 times square root. So let's continue with this example. We did decide the functions u and v, and then we differentiated the functions. So now we want to differentiate the given function f. So f is written as u times v. Derivative of f is f prime x. So this is u v prime plus v u prime. So you want to write this as f prime. U is the first function, which is x squared plus root x times v prime, which is e to the x. V is the second function e to the x times u prime, which is 2x plus 1 over 2 times root x. At this step, I don't want you to simplify the answer, so you're good to leave it. So this is the derivative of the given function using the product rule. In the next example, you have product of two functions. So you decide which part of the function is u and the other part is v. So write this as uv. Bring it down, write u is 5e to the x and write v is square root of x. As soon as you decide the function u and v for the problem, you want to derive each piece du over dx, dv over dx. You might want to think, why did we write du over dx? Why did we not write du over dy or du over dz and so on? The reason is you are seeing a function of x here, variable x, and the right hand side term you are seeing some x terms here. So you are reading the function as a function of x. So the differentiation variable here is x. Okay, now let's derive du over dx. Derive 5e to the x, the constant multiple rule. 5 is a constant. So derive e to the x, it's the same. Now you have a derivative of square root function, which is 1 over 2 times the square root function, which is again by the power rule we just now discussed in the previous problem. Whenever you have a square root function, you always can write 1 over 2 times the same square root function. But understand that the square root function should be a simplest function like an x or a y or a z. It should not have any coefficient. Then you are good to write it as 1 over 2 times square root function. Okay, now that we have all the derivatives, let us write the product rule. F of x is u times v, product of two functions. So f prime x is u v prime plus v u prime. So u is the function 5e to the x. V prime is 1 over 2 times root x. V is the function root x. U prime is 5e to the x. Again, I don't want you to simplify, so you're good to leave at this step. In the next problem, you have product of two functions. So you will decide the part of the function which is u and the second part of the function which is v. So you write u is 1 over x negative 1 over x square. You are good to rewrite this as x to the negative 1 negative x to the negative 2 because it's easy to differentiate if you write in the negative exponent form. V is the function x plus x squared. So once you decided the function u and v, you are good to derive it. Let me write u prime. I'm going to differentiate this. This is negative 1 x to the negative 2 using the power rule. And then it is positive 2 x to the negative 3. Similarly, derive the function v. You have v prime 1 plus 2x. Having differentiated the functions, you're good to go back, plug this in the formula for the product rule. F of x is u times v. F prime x is u v prime plus u prime v. So u is the function x negative 1 negative x negative 2. V prime is 1 plus 2x. And u prime is negative 1 over x to the negative 2 plus 2x square x to the negative 3. This is your u prime times v, which is x plus x square. You can write one step ahead. You can write this as 1 over x square. Avoid the negative exponents. 1 plus 2x, 1 over x square, 2 over x cube, x plus x square. In the next problem, you are asked to calculate the first derivative, f prime, and the second derivative, f double prime, for this given function. You read the function carefully. All you are seeing is product of two functions. So, whenever you see product of two functions, you will be doing the product rule. So let me write the function u is x cubed, the function v is e to the x. Derive u prime is 3x squared and v prime is e to the x. So write derivative of the function uv equals derivative of the function u prime, or let me write the notation in symbols, it's easy for us, and let's have the same pattern in the previous problem. So let me write f of x equal to u times v, f prime x equal to u v prime plus u prime v, plug in, this is x cubed e to the x plus 3x squared times e to the x. So this is your f prime, or the derivative. Now in this problem you want to find one more derivative, f double prime. So when you want to do f double prime, you might want to rewrite the previous step as a product of two functions. That saves your time in deriving. You see that you have e to the x common in both the functions. So I'm going to rewrite this as e to the x times x cubed plus 3x squared. Now I want you to read your function u and v carefully. All this is your function u and the second function is v. So I'm going to write f double prime x is u v prime plus v u prime. Once you write that, you want to differentiate the first function e to the x, which is u, which is just e to the x, and then v prime. So derive the function v. You have 3x squared plus 6x, and then v is the same, x cubed plus 3x squared, but derive the function u, and your answer is e to the x derivative of exponential is the same. You can also write this u v prime v u prime here as the first function and second function. So you don't want to plug in the same u v prime as on the top, which we use for first derivative. So I'm going to rewrite this as first function, second function, derivative of the second function, and second function derivative of the first function. So this is the uv which will be used here at this step. Next is the quotient rule. Suppose you have the quotient of two functions u and v. Say both u and v are differentiable, then the quotient rule says that derivative of u over v is v squared. You are seeing that you are squaring the denominator. Then you start with the denominator v and then u prime minus u v prime. So let me write this in symbols. Derivative of u over v. You always start by writing the denominator square, which is v square. Start with the denominator v, then u prime minus u v prime. I want you to make a note of two things here. The starting function is always v, which is the denominator. And also I want you to make a note of this negative sign here in the quotient rule. So let's do the quotient rule for this given function. Differentiate the following function. So the numerator is your function u and the denominator is the function v. So let me write u is x squared plus e to the x. V will be x minus 1. So now let's derive u prime is 2x plus e to the x and v prime is just 1. Now that we know the pattern of the quotient rule, so let me write derivative of u divided by v is v square in the denominator. Start with v always. I want you to see the starting term and the term in the denominator. They are the same. V square in the denominator and v on the top. If you start v on the top, multiply by u prime, negative sign, u v prime. Now plug in all the derivatives in the function in this formula. So you have x minus 1 times 2x plus e to the x negative u is x squared plus e to the x, and then v prime is 1. So the entire function is divided by v square, which is x minus 1 the square. Again, I don't want you to simplify, so you're good to leave it this step. In the next example, you have quotient form of the function. Assume the numerator is u, the denominator is v. So let me write u is x e to the x and v will be x plus e to the x. So now let's find u prime and v prime. When you do u prime, you see that you have product of two functions. So you want to do a product rule to find the u prime. So it fix x, differentiate x, e to the x, it's the same. Plus fix e to the x, differentiate x, it's 1. And differentiate v, which is v prime, you see sum of two functions. So this is not a product rule. So this is 1 plus differentiation of x is 1. Differentiation of e to the x is the same, e to the x. Now that you finish differentiating, you're good to plug this back in the product, in the quotient rule. So derivative of u divided by v is denominator square v square, and always start with the denominator v, u prime minus u v prime. So this is x plus e to the x square, and then you have v u prime. So v will be your function x plus e to the x, u prime is x e to the x plus x e to the x, then negative u x e to the x v prime is 1 plus e to the x. Again, I don't want you to simplify, so you're good to leave it as such. So plug in for v, u prime, and then u, v prime. Denominator is v square always. In the next example, you are asked to find the tangent line to the given curve at the point 3, 1. As soon as you see this tangent line problem, I want you to write the equation of the tangent line, so you will have a picture of what is the unknown in the problem. So the equation of the tangent line is this: y minus fa equal to m times x minus a. Again, understand this m here is the derivative at the point a, f prime a. So this a and fa will be given for you. This is 1 and this is 3. So all you have to do is find f prime a and then go back, plug in into this equation, and you're done. So let's find f prime a. In order to find f prime a, we have to derive the function. So let's do it. The function f of x is 2x divided by x plus 3. The derivative of the function f prime x equal to x plus 3 the square. You are seeing a quotient function, so you want to write the square of the denominator. Start with the denominator itself. Derive the numerator 2, negative. Start with the numerator, derive the denominator 1. Simplify this by distributing 2 to both the terms. This is 6. Sorry, this is not 6, but rather it is 2. 2 times x is 2x. 2 times 3 is 6. Negative 2x divided by x plus 3 the square. So you're good to cancel the 2x and you have 6 divided by x plus 3 the square. But you're trying to calculate f prime a, and you know this. F prime a is actually f prime 1 because you know a equal to 1. So I can plug in f prime 1, which means I'm plugging in x equal to 1. So this is 6 divided by 1 plus 3 the square. So 6 divided by 4 square, which is 16. Sorry, 4 square is 16, right? I'm sorry, the last plug-in a value, I want you to make a note of this and please change it. It's not 1, but let's read carefully. You're given the point 3 and 1. So read this carefully. The point 3 is your x value and the point 1 is your y value. X value can also be compared to a and the y value is compared to f of a. So your f of a in the problem is 1 and your a in the problem is 3. So you're calculating f prime 3 and go back and plug in 3 here. So this should be f prime 3. So this should be 3 plus 3 the square, which is 6 square, 36. Simplify, you have 1 over 6. We swap the AFA value, which means we are having a tangent line that might not be correct. So make sure the first coordinate is your x value, second coordinate is your y value. Once you find your f prime 3, which is 1 over 6, go back and plug in here. So let's rewrite this tangent line equation. Y minus 1 equal to 1 over 6 times x minus 3. So this equation here will be y equal to 1/6 x negative 3 over 6 positive 1. So y equal to 1 over 6x. Simplify this fraction, you get 1/2. So it's positive 1/2 and this is the equation of the tangent line. In the next example, you're given a function h which is a product of two functions f and g, and you are also given some functional values f at 1, g1 and so on. You're asked to calculate h prime 1. You have to read this problem very carefully. Given a function h, suppose say I give you h is x cubed. I ask you to find h prime 1. All you do is derive the function h, which is h prime x. Your answer is 3x square using the power rule of differentiation. You will plug in x equal to 1, so it's 3 times the 1 square and your answer will be 3. But in this problem, what you want to notice, h of x is not defined. H of x is defined as a function f and g, and again f and g are not defined. So you don't have a nice algebraic expression for the function for which you're finding the derivative value at 1. But well, if you use the product rule, you will be able to do this. So the function h is not given for you directly in the problem. So let's do the product rule to do this. Start with the function h, which is f times g, and this definition is given for us in the problem, so you're good to start with. So let me derive the left hand side, h prime x. When you derive the right hand side, you have product of two functions, so you will do a product rule. Fix f, derive g, which is g prime. Fix g, derive h, derive f, which is f prime. Now you want to plug in x equal to 1 because you're finding h prime 1, plug in x equal to 1. So you have h prime 1, f1, g prime 1, g1 and f prime 1. Now simplify. F of 1 is 0, g prime 1 is 3, plus g of 1 is negative 1, f prime 1 is 2. all the values are given for you. So this is 0 times 0 negative 2. So the answer is negative 2. In the next example, you are given a graph for f and g. F is this pink graph and g is this blue graph. And you're also given that u is f times g and you want to find u prime 1. This is similar to the previous problem. The only difference here is you are not given the functional values for the f and g, but rather you are given a graph. So you should be able to read the functional and its derivative value from the graph and then predict u prime 1. So this is more likely a reading the graph problem. So let me write some interpretation here. F prime means d over dx of f of x. So let me write f prime of x so you understand it's d over dx of f of x. This geometrically means, this is the slope of the tangent line. So start by writing f prime 1, which is your unknown in the problem. This is the slope of tangent line at x equal to 1. Let me write ux, which is f times g, as u prime x equal to f g prime plus g f prime. Understand each of the f g prime or g prime are for all functions of x. So replace x equal to 1. So u prime 1 is f1, g prime 1, g1, f prime 1. Now you want to read the values from the graph carefully. So let's read it and identify the values. The value of the function at 1, f1, and the value of the function g at 1. Look at the pink graph. At 1, the value of the function is 2. So write 2. Look at the blue graph. At 1, the value of the function is 1. So look at 1. Similarly, find f prime at 1 and g prime at 1. So for f prime at 1, you want to look at two coordinates. One is 0, 0, origin, and the other one is 2 and 4, the other value, other edge of the line f. This is 0, 0, 2f. Having known the endpoints, we can calculate the slope, which is rise over run formula. Subtract the y coordinates, subtract the x coordinates, and all you have is 2. Similarly, find g prime 1. 2 minus 0 divided by 0 minus 2, which is negative 1. Now that you have the values for the function and its derivative, you're good to plug in back here. This is 2. And then you have negative 1. G at 1 is 1. And f prime 1 is negative 2. F prime 1 will be 2. Sorry. So now you simplify. 2 times negative 1 is negative 2. 1 times positive 2 is 2. And your answer will be 0. So the slope of the product function u prime at 1, the answer is 0. We'll end this section here.